Hello everyone. Today I'm gonna explain how to solve the spirometric problem. So say given a metric of m and n elements, return all the elements of the metric in spiral order. So from this example, you want to go the top row 1, 2, 3, and then go down 6, 9, and then 8, 7, and then 4, 5. So when you look at this, it's actually easy if you think about it as a reduced rectangle. So first you want to go like the first row, and then you don't care about the first row anymore, right? Then you go down, and then you don't care about the last column anymore. Then go left, and then you don't care about the last row anymore, and so on. Just go up and then go right again. So if we think about it as the border, so if we assign the top border, bottom border, and then left and right. So we can say that, okay, we're gonna go right, down, left, top. It's like up, sorry. And then we're gonna go from, if you go to the right, you go on the top border, from left border to right border. Same for going down, you go from the top border to the bottom border on the right border. So let's look at the code. It might be easier to understand. So the first check, we check if the metric length is 0. We just return an empty array. We initialize top border and left border to 0, and then write to the metrics 0 length, so the length of this one, and then the bottom border is metric length -1. Okay, so we start by getting the count. The count is the numbers, like basically m by n. So this is the count. We just use the count for make sure we can stop the while loop. What I'm doing here is set the mode to 1, which is going right. So it has a comment here. 1 is right, 2 is going down, 3 is going from right to left, and then 4 is going up. And I initialize the result array here. Okay, so let's look at what I did here. So why count? That means if count is not 0 yet, we keep doing this. And then if mode is 1, that means we want to go from left to right. We know that I should start from the left border, and the row we're gonna go do is the top border. We go from why I is not equal, not greater than the right border. So because we go from the left border to the right border. Then we keep pushing magic row and then I, and then increment I, and then minus the count. Then after we go through all the elements on that row, we increase the top border. So first the top border is 0. Then we increment it to 1. So now top border is this row. And then we set the mode to 2, so because we know that, okay, the next one is going down. Doing similar thing here. When the mode is down, we're going from the top to bottom. So I start with top border. The column now is the right border because we fixed the column, right? And then just while loop through it, push metric I, which is changing the row, but fix the column. And then we increment the I and the increment count. After we're done, we say, okay, we don't need the right column anymore, the rightmost, so we shift it right border down. So at first it was here, now it's right here. And then we change the mode to 3. 3 means going right to left. Doing the same thing, doing metric row and I. Row is now the bottom border, so because it's a fixed row, and changing column starting from the right border. We just loop through decrement I and decrement count. After we're done, we remove the bottom border, like going up. So from here, minus minus, go back to here. Now change the mode to 4. Now we're going up, so we start from the bottom. So I is the bottom border. We fix the column, it's the left border. Loop through it, pushing I column, decrement I count. And then after that, the left border move to the right. And mode now change to 1. Back to going left to right. Now mode 1 is going back to, if the count is still not 0, we go back to do, again, in this case, it's going to go back to do 5. And then it's done. So then we just need to return result. Let's run it. Easy. It works. So please subscribe to my channel, and if you want me to do any question, please let me know in the comment below. Thank you so much. Have a good day.